ozone depletion is a small but important topic in your organic chemistry. And ozone, which is O3, three oxygen atoms bonded together, is found in predominantly the ozone layer up in the stratosphere, which absorbs most of the UV radiation that gets to the Earth from the sun, which protects us from that UV radiation. But, and however, this ozone can be depleted, right, broken down, removed by chemicals known as CFCs. And CFCs are chlorofluorocarbons, right? CFC, which are organic compounds made up of carbon, chlorine, and fluorine. So, for example, you might have something like, let me do it over here actually, something like maybe CF2, CCl2, right? Difluoromethane, for example. And how this breaks down the ozone and the equations associated with it, you need to be able to explain and to be able to write those equations as well. So, what happens when a molecule, when a CFC gets up towards the stratosphere? Well, it can absorb UV, and then just like your initiation reactions for your free radical substitution of alkanes to produce halogenoalkanes, we can also get homolytic fission of one of the bonds in our CFC. Now, what does that mean? It means that one of these bonds is going to break evenly, producing two radicals, two unpaired electrons. Now, which bond breaks? Very important question and very commonly assessed question, because you've got CF bonds and you've got CCl bonds. Now, CCl bonds are weaker than CF bonds, right? They have a lower bond enthalpy, which means that out of the two types of bonds, the CCl bonds are the ones that are going to break. And when they break, as mentioned before, let's just get a different pen, these are going to break homolytically, so evenly, which means that one electron from this bond goes onto the carbon and the other electron from the bond goes to the chlorine. So what do we end up with? We end up with two radicals. We get our chlorine radical, right? This chlorine that's taken one electron, let me even draw the electrons, that's taken one electron from that bond. And we will have our CF2 Cl radical, and I'm putting the radical here on the carbon because that's where the electron essentially went to. Okay, now that we've produced these two radicals, this chlorine radical is going to be what goes on to deplete the ozone in our propagation steps. Again, notice the similar language, or the same language really, as when we're talking about free radical substitution. So this is our initiation, or our starting step, which is how we actually get our radicals, and the propagation is how the radicals actually go on to perform essentially the chemical reaction in question. Now, just to rewrite this as an equation, because you don't need to be able to draw these arrows, you would just write this equation as CF2 Cl2, and then an arrow with your UV over the arrow as your conditions to give us your chlorine radical. Doesn't really matter where you put the radical, beginning or end, and your CF2 Cl radical, right? That's your initiation equation for this particular CFC. This isn't the only CFC, but whichever, how many times can I say CFC? Whichever CFC you are given, all you're going to do is break a CCl bond, because again, those CCl bonds are weaker, to give you the chlorine radical, and then the rest of it as a radical as well. Now, let's go to the propagation steps, which are the ones that are going to be the same every single time. Now that we've generated our chlorine radical in our initiation step, how is that going to go on to deplete our ozone? So let's write the equations, and these equations are going to get stuck in your brain. These are going to become muscle memory. So you'll have your chlorine radical that's going to react with an ozone molecule to give us a ClO radical plus an O2 molecule, just regular diatomic elemental oxygen. Now we have got this as our radical, so that's going to go on in our second step to react with another ozone molecule. And when those two react, we are going to get our chlorine radical back, and we're going to produce two more oxygen molecules, right? These are the two steps for the depletion of ozone using your chlorine radical. Now, what do you notice? The chlorine radical was here at the beginning of step 1, but it's regenerated here at the end of step 2. That means what we're going to end up with is a chain reaction because the chlorine radical is regenerated. So that can go on to react with another ozone molecule, and then the chlorine radical would be regenerated again. So it reacts with another one, and another one, another one. It's a chain reaction. You know what a chain reaction is, right? Now, how do we show the overall equation for what's happening to the ozone? What we can do is we can smush these two equations together to show us what is actually happening. How are we depleting the ozone? If we add these two equations together, you will be able to see that everything that's on the, actually, no, let me just write it all out. We will end up with our chlorine radical plus ozone, and then adding what's on the left for our second equation, our ClO radical plus another ozone. That's producing everything on the right, a ClO radical plus O2 plus another Cl radical plus two O2s. Now we can cancel anything that's on both sides and smush together anything that there's more than one of. So getting rid of our chlorine radical, that's on both sides, our ClO radical, that's on both sides. And what do we end up with as our overall equation? I'm actually going to write it up here at the top and kind of make it a new title. We end up with two O3s. Let me just separate that so it doesn't look like 20. Two lots of O3s produces 3 lots of O2s, where our chlorine radical is essentially acting as a catalyst, right? It's speeding up the decomposition of the ozone molecules, but it's not being used up itself because it's being regenerated here at the end. So as a quick reminder, make sure that you can write an initiation equation and you can explain why a CCl bond breaks as opposed to a CF bond, and that you can write the individual propagation steps and the overall equation for the depletion of ozone. Again, the more you practice this, you won't be able to forget it even if you try. And for that, I apologize sincerely, but make sure that you have liked this video, that you subscribed, obviously, and leave a comment if you've got any questions for clarification. And I will see you in the next one.